All right. Hello again, guys. All right. This is lesson 12-5. You should turn to your book to page 673 and be ready to take some notes here. So this unit is on vectors. You talked about vectors in physics, and I'll try not to do anything with vectors that's going to contradict the way you were learning in physics. The book talks about aviation. There's a picture there of the Tuskegee Airmen. You may have seen there was I think Showtime when somebody did a movie called The Tuskegee Airmen, and then Hollywood did a movie about the Tuskegee Airmen called The Red Tails, which is mainly not so much about their origin, but about their experiences flying in World War II. So that's pretty interesting to watch. But pilots use vectors when we're figuring calculating flying with what's called dead reckoning. Then the airplane is flying in a certain direction at a certain airspeed, but the wind is also blowing in a certain direction at a certain airspeed. And so those are two vectors that are working against each other or maybe helping each other. But we do have to do vectors, and we actually draw those out on something called a circular slide rule. And we use that to calculate exactly what heading we need to fly a certain course to account for the wind. And then we also use that to calculate if the wind's hurting us or helping us with the fuel. And so it gets fairly involved. So that's basically vector. So a vector looks similar to a ray, except we just have one side of the barb, okay? So a vector has both magnitude and direction. Vector has magnitude. That is, it has a length, and it also has direction. And in our terms, in mathematics, direction means in terms of a coordinate graph. And so if we have a vector, we can name vectors in several ways. If this is point A and this is point B, then we could call this vector A, B. We would have the symbols as in an array, except again, it's only a barb in some direction. If we want the magnitude, in the magnitude, we would put the absolute value symbols around it, and that would indicate the magnitude of vector AB. A vector can also be named by a lowercase letter as well. We could call this vector A. Okay, so we can do it that way. But if we're using a coordinate system, then we use the points that represent what's called point A, which is the initial point, and point B is the terminal point. So a vector can be either in standard position. Standard position means that the initial point, the initial point of the vector is at the origin. Okay, so standard position means the initial point is at the origin. If you think my handwriting was poor before, we just ran out of room there too, okay? And try it now. I'm trying to write across the board further and further away from me, okay? All right, so that would be standard position. And we could also name a vector by using an ordered pair, okay? So basically, a vector can also be written, so vector CD could also be written as an ordered pair. So it has an X value and a Y value. And basically, if point C has the coordinates X sub 1, Y sub 1, and point D has the coordinates X sub 2, Y sub 2, and it's almost kind of a distance thing there, okay? Now we can see that. Then it becomes kind of, if it's in standard position, we don't have to worry about that. We just need the coordinates, but if it's not in standard position, we need to calculate that. And so basically, then this right here would become X sub 2 minus X sub 1, and this would become Y sub 2 minus Y sub 1. We'll get to practice that some on the homework. So to find the magnitude then, in this case, we would have to use the Pythagorean theorem of the distance formula, okay? Again, technically we use the distance formula. Remember, the distance formula really is using the Pythagorean theorem. So you could use x squared plus y squared, a A squared plus B squared equals C squared. So we can use that, and then define the direction of a vector. We would use trigonometric ratios, sine, cosine, tangent. That's how we would determine that. So your direction would be an angle. All right. If you look on page 674, it has an example. So let's look at that example on page 674. Not necessarily going to repeat it on the board. It says, given point C at 8 and -2 and point D at 4 and 6, find the magnitude and direction of vector CD. Okay, well, notice that we're going to do the distance formula, okay? Distance formula, remember, is the difference in x value squared but the difference in y value squared. So that's what they gave you. And it ends up being the square root of 80, about 8.9 units. In direction, of course, direction is tangent, okay? Direction is going to be tangent. And so, again, if you draw this on the coordinate plane, then you can count horizontally, you can count vertically. Remember, tangent is the length of the opposite leg or the length of the adjacent leg. So that's a little bit of a counting process. And then you just go to your calculator and do the inverse tan, and that will give you the angle, and it will give you the direction. We do that to the nearest tenth. All right, let's stop there for the moment. And let's go to the assignment, okay? So this is homework number 13, I believe. Okay. Homework number 13, and it's number 17 through 42 on pages 67-678. This will also be when you're looking at this lesson in Google Classroom, it will also give you the assignment there as well. So we're going to do part of these now, and then I'll leave some of them for you to do for homework. We'll do a couple, and maybe about 3, and then we'll leave the rest for you. All right, so you need your calculators and anything else you need to do the assignment. Of course, you can always stop, and you should do this. And it's helpful to do this on graph paper. Okay, you don't have to do it on graph paper, but that would be helpful. Okay. All right, graph paper is going to be the easiest way to do this. So number 17 is the first one. Look at number 17. I'll go ahead and erase the assignment because you can have it written down or pause the video or whatever. Okay. So 17 says vector AB is 1 and 4. Okay. All right. So that means from standard position. We're talking about from standard position. So if we go 1 and we go 1, 2, 3, 4, then the vector goes like that. Okay. So that would be my vector AB. So sketch that, and then to find the magnitude of vector AB, well, this distance right here is 1. This distance right here is 4. So basically, it's the square root of 4 squared plus 1 squared, which is 16 plus 1, or the square root of 17 would be the exact answer. If you want an approximate answer, then that's a little bit over 4, right? 16 squared is 4 squared is 16, so approximately 4.1 would be your magnitude. All right. So to find the direction, then that would be the inverse tan of 4 over 1. Okay, so you go to your calculator, make sure you're in degree mode, and you do the inverse tan of 4, and that gives you, says to the nearest degree, it gives you 75.9, so that would be approximately 76 degrees would be the direction, okay? Pretty simple, right? 18, you would do the same way, right? Let's look at 19. So 18 would be like this, except the vector is 4 and negative 9, so it's 4 and negative 9, so it's down here, but you're still going to have 4 this way and 9 this way. All right, so I'll leave 18 to you. We'll do 19 together. And then 20 through 22 are also yours. All right, these, they give you both points. So this is a little different. So now when you sketch your vector, and for 19, point A is at 4 and 2. So 1, 2, 3, 4. 1, 2. A is right about here. And then point B is at 7 and 22. 4, 5, 6, 7, 22. Tell you what, we'll call this 2, 3, 4, all the way up here. So you're going to have to make some room for that. So 722 is going to be way up here someplace. All right. So vector is going to look something like that. All right. So the magnitude of vector AB in this case is going to be the distance formula, okay? Because it's going to be the difference in x value squared plus the difference in y value squared. So point A was 4 and 2. So we'll put 4 here and 2 here. And point B was 7, 22. We'll put 7 here, 22 there. So 7 minus 4 is 3 squared. 22 minus 2 is 20 squared. So obviously 20 squared is 400. So this is the square root of 409 would be your exact answer. And that's going to be approximately what, 20 point something, right? Approximately 20 point, let's see what that is on your calculator. 20.2, approximately 20.2. All right, so that means this distance is 3, this distance is 20. So the direction is going to be the inverse tan of 20 over 3, okay? So you go to your calculator again. Second tan, 20 divided by 3, and it's 81.4 something, so that would be approximately 81 degrees, right? And that's how you would do 20, 21, and 22. So that's a fair amount of work, okay? This assignment, if we're doing this in class, we're going to spend several days on it, so you can feel free to stop the video, and when I'm done here, you can stop the video and go back and finish those. All right, well, you can stop right now and finish all those assignments before you move on. All right, 23 through 25 says, given a path from A south 25 units to B. So basically we have A, we go south, let's call that down, 25 units. And then we go east, that would be to the right, 10 units to C. So this is A, B, C. Answer each question. What's the total length of the path? Well, the path is from here to here. So the total length of the path is 25 plus 10, which is 35 units, okay? That's number 23. All right, 24 says, what's the magnitude of vector AC? So that would be vector AC would be right here. So the magnitude of vector AC is going to be the square root of 25 squared plus 10 squared, okay? 25 squared is 625, 10 squared is 100, so that would be the square root of 725 exactly. And to the nearest tenth, that would be, obviously got to be bigger than 25, approximately 26.9 units, okay? All right, and then 25 says, what's the direction from A to C? All right, well, the direction from A to C is going to be my tangent thing, an inverse tan. Now the direction is down, so the answer is going to be negative. So it's going to be the inverse tan of 25 over 10. So go to your calculator, second tan, 25 divided by 10, and that's going to be 68, has to be negative, so that's going to be negative 68 degrees would be your direction, all right? Okay, that gets us up to 26. And again, if you haven't done it yet, you want to pause and finish everything 17 through 25 before we go on with the lesson. For 26, we're going to go back to the lesson and do a couple parts here. Again, feel free to spend a couple of days on this. You've got a couple of days to spend on. All right, we go back to page 674 underneath example 1. It says two vectors are equal only if they have the same magnitude, same direction. So equal vectors means same magnitude, same direction. That should make sense. If the vectors are equal, they have the same distance, they're going into the same direction. Those are called equal vectors. This is where it gets a little confusing, okay? Parallel vectors would then be vectors that are going in the same direction. In other words, they have the same slope. Parallel vectors, same direction, that would be same slope. Slope is direction, right? Okay. All right, so if you look at the page there, it shows you some examples. And if you look at the little graph, it says that vector RS is parallel to vector AB. RS and AB are parallel. They're not the same size, but they are going in the same direction. Okay. Vector RS and vector KL are equal. They have the same magnitude and they're going in the same direction. Vector RS, if you find vector RS, and vector EC have the same magnitude, but they're not going in the same direction. So they're just not equal, okay? Vector RS is not considered to be parallel to vector TE because they have opposite directions. That's a weird thing. It's opposite directions. You have to go the direction of the vector too. All right, we'll get to that on the assignment, but let's look at what the next thing is. It talks about a vector can be multiplied by a constant that changes the magnitude of the vector. That's what's called scalar multiplication. So again, pause, whoever notes you want to do here. Scalar multiplication. Scalar as opposed to vector. Scalar just means numbers, okay? I know I run out of direction. All right, so scalar multiplication. Scalar multiplication does not change direction, it only changes magnitude. All right, so if vector V is 1 and 5, then 3 times vector V would be 3 times 1 and 3 times 5, which would make it 3 and 15. So that's pretty simple math, okay? Pretty simple math. That's scalar multiplication. Very easy to do. And then, of course, that would change the magnitude. So we have the same direction, but we change the magnitude. And whatever the magnitude is of vector V, 3 times vector V should be 3 times that number. So that's called scalar multiplication. It's also possible to add vectors. And that's basically what we did in flying when we were figuring the wind. We were adding the vector for the airplane and adding the vector for the wind and see what we got. What we got was called the resultant. And there are really basically 2 methods of doing resultants. But we're just going to talk about one. And we're going to talk about called the parallelogram law. Okay. So basically, if I have a vector that's going like this and a vector that's going like this, and I want to add those vectors, then I just complete the parallelogram. I complete this segment right here. I complete this one out here. And then if I draw the diagonal of the parallelogram, then that gives me what's called the resultant vector. Okay, so that's one method. There's another method called the tip-to-tail method. But basically, this is the method we use here. Okay. Vectors can also be added just by adding their coordinates. All right. So basically, if vector A has coordinates A and B, and the other vector has coordinates C and D, and if I add those together, then it's just going to be A plus C, and then B plus D. Pretty simple math, okay? Guys, it shouldn't be a terrifically difficult one to do the math. Pretty easy to do, okay? All right, and let me show you one last thing. We would break this up more, but the book's kind of weird. So one more thing. And if you look on page 676, it's also possible to write vectors as a column matrix. Matrix is just an ordered array of numbers, okay? So if I have a vector, if vector V is 4 and 2, then I can also write it as a column matrix with the X value on top and the Y value on the bottom, which I can also use just to add and subtract too, and multiply. Look at example 3. Vector V is 3, 7, vector U is 4, -1, and what's the sum? Well, vector V plus vector U would be basically 3 plus 4, which is 7, and 7 minus 1, which is 6, so it would be 7 and 6. All right, let's do that's the next part of the assignment, so let's go back to your assignment, and this is 26 through 31. That's all you're doing on 26 through 31. So let's do a couple of those. So 26, we have vector which is 9 and 21 plus a vector which is 8 and -2. All right, well, 9 and 18 is 17, and 21 minus 2 is 19. I won't even make you show your work on these. Okay. Pretty simple, right? Now, notice you can also subtract vectors. Okay, let's look at 29. Okay, that was 26. Let's look at 29. All right, 29, we've got 12 and 4 minus 4 and -1. All right, so 12 minus 4 is 8. 4 minus -1, and negative times a negative is a positive. 4 plus 1 is 5. So this would be 8 and 5 would be my answer. All right, so that's how you do 26 through 31. That's pretty simple. What I would do is just pause your vector right now, pause your video right now, finish those up because they're really, really easy. And before we go on, so pause the vector, pause the video. Too much vectors here. Pause the video and get those done, and then we'll go to 32. That's on the next page, 671. 32 through 34, sorry, gives you a bunch of vectors there, and it says draw the vectors, okay? So this is what you're going to do is end up with something that looks like, if you go back to page 674, underneath example 1, you had a graph there with a bunch of vectors on it. All right, so you're going to do the same thing. You're going to graph all those vectors, all right? And then you use a diagram to answer each question and explain your answers, okay? All right, so you draw the vectors. This will be easier if you use graph paper and draw this more accurately. So it says, which vectors are parallel? Remember, the vectors are parallel if they're going in the same direction, even if they don't have the same magnitude. Now, I'll accept your work in two ways. If you will put this on graph paper, then I'll accept that you can measure and figure this out just by looking. If you don't do it on graph paper, then you got to do distance formulas and slope formulas. So I would suggest graph paper. So which vectors are parallel, sorry, those would be the vectors going in the same direction. Okay, so it'd be something like vector AB is parallel to vector CD. It might even be parallel to some other vector, okay? All right, and then you might have a different set. Maybe vector HJ is parallel to vector KL or something, all right? So that's 32. Then 33 says which vectors are equal. All right, to be equal, they must be going in the same direction and have the same magnitude. So again, if you draw your graphs accurately, I'll accept that as your work. If you don't, then you have to do distance formulas to decide what has the same. And then 34 says which vectors have the same magnitude. And remember, they could have the same magnitude and not be going in the same direction. So again, you can either use distance formulas or you can draw your picture. That's up to you, all right? All right, so pause the video and do 32 through 34. When you're done with 32 through 34, come back to the video. All right, 35 through 38 says, given quadrilateral ACDE, complete each statement. We'll do this together, okay? All right, 35. So what I want you to do is draw the picture, okay? So redraw the picture. That's your work, okay? Since I'm going to help you do this, then that's your work, okay? So this is A, B, C, D, E, right? Okay, 35 says vector AE. So this is vector AE plus vector AB. This is AB equals what? Well, it says that ACD is a quadrilateral. So that means we're going to use the parallelogram method, and we're going to assume our answer is right here. So the answer to 35 would be vector AD, okay? Pretty simple. All right, let's look at 36. I'm losing my graph here, okay? All right, 36 is vector BC. All right, this is vector BC plus vector CD. All right, vector CD is here, okay? So basically, in this case, we have a different parallelogram. So essentially, we got BC, AD. So this actually is it right here, okay? So this would be vector BD would be the sum, right? Okay, let me erase those two. Falling apart here. All right, 37 is, I need to change colors here. All right, 37 is vector BA. All right, so BA would be from here to here. And vector AE, so this is AE, all right? So that would make it basically from here to here, which would make it vector EE, right? And then 38 is vector EB. All right, so this is EB right here. Make that big vector EB plus vector ED. This is ED. So basically then this would be, my answer would be vector EC, right? Okay, we did that together. And then the last part, we'll talk about the last part. You know, this is not due until, was it May the 4th, I think, something like that. All right, 39 through 42, those are the ones that are left there. 39 through 42 is a given vector V, 3 and 1, vector U, 5 and 8 represent vector W as an ordered pair, okay? All right, so 39. We'll do 39 together, and then I'll let you all finish, okay? So 39 is vector U plus 2 times vector V. All right, I'll give you a choice here. You can do this doing scalar, I mean, with the column matrix if you want to, or just a normal vector. All right, so vector U is vector U is 5 and 8. Be careful of the order there. Plus 2 times vector V, and vector V is 3 and 1. So just basically arithmetic. So we have 5 and 8 plus 2 times 3 is 6, 2 times 1 is 2. So that's 5 plus 6 is 11, 8 plus 2 is 10, and my answer is 11 and 10, which is pretty simple. And that's what you're doing with 40 through 42, right? Okay, so that's it. So basically, This would be done, we would have done this in 2 days of class, so you can stretch it out however you want to. So basically you've got, this is your third assignment for next week. That only leaves one lesson in the chapter, and we'll do that the following week, plus test review, and probably start the next chapter before doing the test. So have a great day and enjoy.